think the E.
Oh, which one?
I actually because I actually got stuck on the I separated it and then like got confused.
Yeah, I mean we both of these are e to the u, but this one has no changes, so they'll just stay as e to the x. This one, that if the u value is negative x, it'll produce a negative 1. So the negative 1 is going to carry over into the nth. It is, yeah.
Why would it make it?
Because if the u value is something produces like a negative 1, let's say it was e to the 4x, right? It'll produce a 4, and then the 1/4 will show up. Negative x will produce a negative 1, and negative 1 will remain. Right. It's a leftover, right? Anything that is leftover. There is derivative for x, which is 1. So technically there's a leftover 1, but we know that's not changing anything, so we don't include it. Okay, so let's look at page 13. Okay, so first thing we see is, well, there's one term below, but it's not like as if we can split up into individual fractions. There's only one term above. So we know u substitution is going to be our next option. So what could be our u value here?
Natural.
Hmm?
Natural log of x.
Yeah, natural log of x, right? We don't want to let that squared to be part of the u value, because if we do, then it'll produce a whole chain rule, and we know that there's nothing here that will match the chain rule that's going to come out of this whole thing. So just natural log of x, and we're hoping that will take care of the x, right? The 5's not an issue. It's the x that we really have to be looking out for. Okay, what's the derivative of natural log of x? Yeah, u prime over u, right? 1 over x. Cross multiply. All right, make our substitutions. Natural log of x is replaced with u. 5x stays initially, and then dx is x du. Okay, so that's a good sign, right? The x's do cancel out. We do have a leftover coefficient, 1/5. All right, everything is nice and clean here. What rule can we use here? Okay. So we've done the we did the calculus step here, and now it's just clean up, right? Cleanup just means we started with X variable, we got to end with X variable as well. You can pull that 15, 1 over 15 in front, you can put that 15 below the parentheses. Either is fine. Because there's a 3 here as well, so I just multiply 5 and 3 again.
Are there other weird derivative things I was gonna, or just natural? I forgot about them.
Oh, if you look on page 7, we have our derivative rules there, which is just
Because I just like missed the other. I know the others, yeah.
yeah, that's it. I mean,
I just forgot that.
the strange ones are these two, which I'm not going to put on the quiz. So, power rule, trig derivatives, e to the u, and natural log.
Yeah.
Yeah, then yeah, you're good. I'm not going to put these on. I'm not going to put these on the quiz.
Okay.
Okay, number 2. I'm sorry.
I thought that was that not?
Oh, we're doing it on page 13.
Is that?
Oh. Number 2, no. Number 2, we can handle it. Okay, so our first option is, can we expand and distribute and split up into individual fractions? There's obviously more than one term in the denominator, so we're stuck. Next option is use substitution. Can we try to find a u value that could fit with this problem? Denominator looks like it looks like a lot, right? But if you look at the degree here, 4 to 3, 3 to 2, 2 to 1, that should be a pretty good fit. Let's try it though. Okay. Okay, so u value, denominator. Cross multiply. Divide that whole thing over. Okay, make our substitution. So we would like to cancel the numerator and denominator out. I mean, the degrees are pretty well matched up, but the numbers aren't. We can't just pick and choose and just do, right? What algebraic steps should we take so we can have a clear view as to what can stay and what can go? Factor, right? So take out the GCF. Maybe not GCF. Let's take out the GCF of the numeric value. It looks like my variable is okay. So here I can take out a GCF of 7. Denominator, I can take out a GCF of 4. Now there's a good match, right? This can go with that. Right, what can we push out? What leftover do we have to keep track of?
So
7/4. And we have a nice clean integral, right? Antiderivative of 1/u du. Okay, we're ready for our calculus step. 1/u becomes
natural.
natural log. And then bring the x back into our answer. All right, question here. Okay, next up, number 3. Okay, let's go down our list of options here. Number 1 is, can we split up into individual fractions? What can we say? No, right? Too many terms below. If it was just x, then yes, we can split up. But that x plus 2 makes it more difficult to do that. Next option is use substitution. Are either side good fits for our u value? No, we can't. Yeah, if we think about the derivative of either side, we can't get the derivative to match the other side. So what's our next option here? What does this look like? Yeah, this is synthetic division. Okay. Not to solve the problem, but to clean up and give us a different look of this problem. It basically will do the job of what we would want power rule to do or expansion to do, which is split up. So we're going to try to find a way. This will help split this up into basically 4 separate problems for us to explore. Okay, so first things first, set the denominator equal to 0. We're going to use what? X equals -2. So -2 will go outside your half box. And we're going to put just numbers that represents the coefficients of each of the degrees. What do we want to? Well, we see the 4th degree being the first one, so that's where we're going to start. What number, what coefficient will represent x to the 4th? 1. And then for x to the cube, we're going to use 3. For x squared, we'll use -1. For x, we'll use 0. Notice that it's missing an x degree, but we still need to have a place for x degree. So we'll have a 0 if we don't see that degree, if we see a degree being skipped over. And then finally, the constant -5. Are we good with this setup? Okay, next up, bring the number down below the line. Okay, multiply. 1 times -2 is -2. We add. Multiply again. Add. Multiply. Add. Multiply. And add. Sorry, I messed up here. 1. Sorry, 6. My bad. Good so far? Now we're starting with degree x to the 4th, but we're dividing by x to the 1st power. So what's going to happen with that first term? Becomes x to the 3rd. Okay. Every term is going to have a degree 1 lower than where we started. So x cubed, followed by x squared, followed by x, followed by the constant, and then the leftover is your remainder. Make sure you divide it back with your original divisor there. Okay, remember, we haven't done any calculus yet, right? This is this only gets us to that starting line so that we can actually apply rules that are easier to use. So it's nice that we now have 5 terms, and each term will get its own rule. The first 4 terms, we can just use what rule? Power rule, right? And the last term, we can use substitution, right? The u value being the denominator, and it's going to be a simple natural log rule. So you can jump from here directly to the answer, to the antiderivative, or if you want to see all the steps here, we would do this. But you don't have to show all the steps, just in case you feel like you want to. Okay, so let's do the calculus for each of the terms here, power rule for the first 4 terms. So if you're comfortable, you can jump from here to here without showing any of the u substitution steps, because this is a relatively easy. We know the u value won't produce anything other than 1, so nothing to keep track of. Okay, number 4. All right, so we see bounds in our in this depth integral problem. We're not going to be using the bounds to begin with, so if it helps, maybe rewrite the problem without the bounds so that you don't have to, but just so that we're not getting distracted by those numbers when it's not part of our process yet. All right, so I think we saw something like this yesterday, right? Too many terms in the denominator, we can't quite, we don't want to be, we can't split up into individual fractions. Our u substitution, what could be our u value here? Yeah, 1 plus root x. The idea is that we want to identify a u value and we want to save something for the derivative to match up and pair up with. Let's get that u value ready for our power rule. Let's do some cleanup here. I'm going to bring that x to the 1/2 back to square root of x because I'm just anticipating that makes it easier to visually see that connection and the canceling out that I would hope to have. Cross multiply to get dx by itself so we can find a replacement or substitution for dx. Okay, so now back to our problem here. Replace 1 plus root x with u, replace dx with 2 root x du. See where we are. Numerator, denominator pairs up, cancels out. So there is a leftover of 2. I can push that 2 out in front. Here's my calculus step. 1 over u becomes natural log of square root of u. All right, what do we do after this? All right, do we start using 9 and 4 here? One more thing we could do what? Yeah, let's get the, yeah, you can change the intervals in terms of u. That's what I did on my solution key. But I think most students prefer this other method, just bringing the u back in terms of x and then use the original balance. But if you want to go through that method, look at the key and we'll, we can arrive at the same place. But I'm going to do just this way here. Bring the x back. And then use 9 and 4. Upper bound first. So root 9 is 3, 1 plus 3 is 4, so 2 natural log of 4 minus 2 natural log of 3. Okay, number 5. I just cleaned this up here. What's root 9? 3 plus 1 is Okay, 2 cotangent 3x minus secant of 4x. Are these independent of each other? Yes, so we can just find the rules appropriate for each. These are both new rules, right? Ones that involve natural log. So let's just recall what those rules are and we can come back to them. So what's the rule for cotangent of u? We know cotangent is cosine over sine, so that denominator will show up. So natural log absolute value of sine of u. Let's see, right? Cotangent is sine over cosine. So, oh, sorry, my bad. Cosine over sine. So that's why that sine shows up. Are we good there? And a secant. Secant also involve natural log, but it kind of looks like the derivative rule in the sense that 2 trig functions that we associate with secant shows up. But we got to make sure we put a plus in between those 2 terms. Yeah, cosecant is negative. Yeah, these don't matter, right? As long as you have both of them inside. Okay, but we're gonna follow these rules here, but the 3x and 4x, we have to do what within each? A little bit of what? Yeah, use substitution, right? We gotta know what, there's gonna be some leftover that we gotta keep track of. Okay. Let's just write this out twice so you can see the full steps here. Okay, any questions? Now, there is a bit of a shortcut if you choose to take it, but just be careful because it's easy to mix this up. I'll just show you if you feel like you want to do it. For linear linear u value, like 3x or 5x or 6x, what's that? What do you think the relationship is? That 3x is going to turn into a what? 1/3. That 4x is going to turn into a what? 1/4. So it's like the opposite of chain rule, where chain rule is times 4, but now it's going to be times 1/3. So if you can see that, you don't have to go through this whole step. If you just see, oh, that's a 3x, I know it's going to be times 1/3. You can literally jump from here to here if you can see that. But I don't want to mess you up and throw off your rhythm. So, this is the full step. but if you jump from here to here without showing any of these steps, I'll still give credit because this is an easy enough U value where I can see that jump from here to here. And then that 4 will produce a 1/4. But I don't want you to feel like I'm making you guys do this. And I know that that's just adding another thing to memorize if you want to do that shortcut. So it's just up to you. But the safe way is to go through the full use substitution so that you can not have to memorize, you just have to go through the same stuff, to go through the process. Yeah, done to simplify. Yeah, there's nothing we do to simplify here. We can't distribute the natural log, and this is inside the natural log. So even if we wanted to simplify, we couldn't. No, yeah, we only do a plus C at the end because both plus C's added together are still plus C. So. All right, number 6. All right, it's not like if we can just jump into a rule. There's too many things going on here. So our next option is U substitution. What could be our U value? Well, if we do x squared being the U value, the derivative will be 2x, but the 2x is not going to be able to handle an exponent, right? We can't cancel an x in the exponent.
We just get the 2/x.
Oh, yeah, it got covered up. If you look at the key, I have it. Sorry, it got cut off. It's 2/x. Sorry. So yeah, this is not going to be our good U value because it's not going to be able to cancel out an exponent variable. So what's our next option?
The exponent.
The exponent. It feels like this 2/x is not going to be able to do much to help with the x squared, but notice the x is in the denominator. It's not 2x, it's 2/x. So when we get it ready for power rule, it should do something that will pair up nicely with that. Okay, so we're focusing on the exponent here. Okay, 2/x can be rewritten as, right? Okay, then we can do power rule. Derivative is, there it is, right? The x to the -2 shows up, so that should eventually help out with this x squared that we're waiting for. Okay, let's do some cleanup though. Cross multiply. I think we make our substitutions. All right, do the x's go away? Yep, x squared, right? That's good. What can we do to push out what? Now the 7 is not a coefficient. This is stuck to the u. This is a function here, so we can't touch that 7, but we can do a -1/2. Okay, so just make sure that we don't think of that 7 as a number 7. This is a 7 raised to the u. This is a function, exponential function. All right, do we have a rule for this? Yes, a to the u, right? Good. So let me write that rule here so we can follow it. What's the rule for a to the u? Good. Times c. All right, so we're just going to follow that rule there. All right, the negative 1/2 stays. Next up. Times. Yeah. Plus. All right, so we did our calculus step. One more thing to do. Yeah, bring that u, replace the u with 2 over x. So this is acceptable, or you can merge this together, or you can put it all under one fraction. Okay, any ones from the previous worksheets that you guys want to try?
You do 4 and 11.
Uh,
Keep 4 on page 11.
okay. Yeah, good. Let's do that one.
Would it be an E question?
Mm-hmm. It's a possibility, yeah.
After you-
Yeah, okay. So page 11, number 4. Okay, so the first thing we should explore, can we split this up into individual fractions?
Yeah.
Yes, because why?
As
The
the
denominator only has what?
one variable.
Only has one term, right? So this allows us to separate, and that's good because now we can think of this as 3 smaller problems rather than just one extended connected problem. And we can just treat each independently and clean up independently as well. All right, how do we resolve this, right? We can't have e's all over the place within each fraction. Yeah, okay. How do we do that? Yeah, subtract exponents. 2x minus 1x is just what? Just e to the x, okay. Okay. I'm just doing this for visual purposes. If we just split up into each individual integral, you don't have to, but it just feels like it's more independent that way. What does this become?
Just 2.
2. This, yeah, we know that we have a rule for e to the u, but the e to the u has to be where? In the numerator, right? We don't have an e to the u rule in the denominator, but we have an e to the u rule in the numerator. We bring that e up as e to the negative x. Okay, so for the first and third rule, we'll just use e to the u. For the second one, we'll use what? Or what's it? It's just 2 dx. Yeah, just power rule, right?
Oh.
So 2 becomes 2x, yeah. If it was 2 to the x, then we would use a to the u. So for these two, use e to the u du. So that's what we're after, right? So this one, looks like it's just an x, right? I mean, we can go through u substitution, but what's x's derivative? Just 1, right? So we don't have to go through u substitution because nothing will come out of x except 1. So the integral of e to the x is just what? Just e to the x, right? So we don't have to go through u substitution if our u value is just an x. This is just literally the same replacement there. All right, 2 becomes.
Like what's like when would you have to go through your substitution?
If your u value is more than the x. Yeah. Okay, 2 becomes 2x. Now this one fits nicely with e to the u, but is this more than the x?
Yeah.
Yes, so we should go through u substitution because we know something is going to come out of that. Right. The whole point of u substitution, not only is it cleaning up our problem to help us identify a rule that we can use, it also keeps track of the leftovers that that we need to include. Right, so I'm going to do a separate process here. So my u value is negative x. Du dx is negative 1. Make my substitution here. Replace the negative x with u. Replace dx with negative 1 du. Do some cleanup here. I can push that negative 1 out in front. What's the integral of e to the u? That's e to the u. So negative 1 times e to the u. I have my antiderivative, but now replace the u back in terms of what? So u gets replaced with what? Negative x. Yeah. So then we can bring that up.
Determine the value for this.
Because, oops, sorry, plus c. Because I saw that this looked very similar to this e to the u rule. So it just made sense to me that I'm gonna work towards this rule because that's the closest match.
How come it wasn't positive x instead?
Over here.
Yeah.
We could have. So you're right. We could have done u substitution, but I'll show you what's there here. So my u value is x. My du over dx is 1. Dx equals du. Integral of e to the u du becomes e to the u becomes e to the x. So nothing changed. So that's why I didn't go through u substitution, because my du dx didn't produce anything other than 1. So technically there's a leftover 1, but that leftover 1 is not really changing my process. So I just skipped u value, skip u substitution. So if my u value is more than 1, it's more than x, then I typically go through u substitution because I know there's leftover. I mean, it's not wrong if you want to go through u substitution for everything, if you want to just do the same process. Just be careful, right? We can't do u substitution for problems that are not meant for u substitution yet.
Yeah.
Let's see which one's.
Yeah, for number 5, your u value is just 3 over x, and it's going to cancel out with that x squared. It's going to feel a lot like the last one that we did, but instead of a to the u, it's going to be e to the u. So yeah, see if you can try those steps on your own, see if that will fit. I can put the work up as well.
Take a Chromebook after.
Yeah, so we'll skip 6. Don't worry about that.
Oh. He's on 8.
8, yeah, 8 we can skip as well. I'm not gonna have that 8 to the U derivative rule. Oh, sorry, it got cut off. So, yeah, I have it on the key. He has it. It's like I think I was, yeah. We can spend the past day today. Yeah. I don't know why they pick for you here.
Oh.
You gotta do this. You have to put into the option. The reason why I don't, calculus do it this way, because as soon as you do it this way, it end up just multiplying with the last term, and then they forget to distribute this still. So you can do this and distribute, and you'll notice things that I can.